So here's, what does this look like? I mean, you can go back to the previous section where I worked it out before, but since you guys are not rattling it off, I assume you didn't learn it. Am I right? Can you tell me what that is without? The one, no, oh, not a bad thought, but you're thinking of this one. That's A1 too, but you're not off. I mean, that is related, but not the same pattern. This should still be a matrix. I'll get you started. This is column 1, right, of A. What is it? What happens when we multiply column 1 of A times E2 transpose? What's that do? Let me write it out. I mean, this here, I'll write it like this. This is column 1 of A times 0, 1, 0, dot, 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 0, right? So the way that works is 0, column 1 of A, zeros, right? Put it into words. A times E1, 2 is the mostly 0 matrix, right? Where the first column of A has been moved into the second column of the resulting matrix, yeah? What about if we do the other way? What if we do E1, 2 times A? What's that? E1, E2 transpose A. Remember what E2 transpose A is? That was row 2 of A, right? So what's this? So we've got 1, zeros times row 2 of A. What's that? What's that do? That multiplication does what? That's a mostly 0 matrix with row 2 in row 1 of the resulting matrix, right? And those two things have to be equal, right? I mean, that's the assumption. If A is in here, AB is equal to BA for all B. This is a particular choice of B. These have to be equal. What does that tell you about column 1 and row 2 of A? Let's start with column 1. What does it say about column 1? Let me write it in the same stupid line so we can better appreciate it. Column 1 of A. So wait, what did you say again? Column 1 has to be a multiple of E1. So in other words, everything except for the first entry in column 1 is 0, right? Because look over here, right? That's 0, right? So if you can, parse it. So everything except for the first component in column 1 is 0. How about row 2? Right. Repeat this for I and j arbitrary. See, because I just did it for 1, 2, but you can just as well do it for 1 replaced with I and 2 replaced with j, right? And really, if you just focus your attention on the column comment that, what was your name again? Liam, that Liam made. If we just, focus on the column comment for arbitrary ij, we'll figure out the answer. Well, you should also think about I equals j. You can get a little bit more. You can get a little bit more than just that it's non-zero. So, to put words in your mouth a little bit, I mean, basically you're finding that it was non-zero off the diagonal of the matrix. Because you just figured out that only the first component of the first column or the second component of the second row could be non-zero. Those are on the diagonal. So I wanted to tell you guys a few things, because usually I just let students wander off on their own and play with this, and invariably I'll find people with sheets and sheets and sheets of big, dot notation matrices, and then it's very easy to spend hours and hours and hours in this problem and get nowhere. You must go in with a plan and use the right notation, otherwise it will beat you down, this problem. I mean, it seems relatively simple, but I trust me, if you don't use the right notation, this problem is very difficult. Any other questions, you guys? Do you guys understand how to start? So, by the way, the problem 50 is a determinant problem, right? So if you have B is equal to P inverse AP, right? What's the determinant of B equal to? But then we know the product identity, right? Which we can apply multiple times. One of the things I have not uttered in class yet, but is easy to derive, is that the determinant of P inverse would be 1 over the determinant of P, right? That's not hard to prove. So, or you could rearrange them. Anyway, however you want to see it, these cancel. And so, if B and A are related in this way, they must have matching determinants. So that is perhaps helpful for problem 50. Maybe a little too helpful, sorry. But one of the things I was going to tell you is for problem 51, 52, 53, and 54, these are really not about determinants. These are just leftover basic, matrix manipulation, linear independence type questions. It really has not, as far as I can remember, much to do, if anything, with the determinant. I guess if you're a glutton for punishment, you could change 51 into a determinant question, because I have given you n vectors in Rn, so you could chuck them all into a matrix and do row reduction somehow or whatever, prove that the determinant's non-zero, and get linear independence that way if you want, but that was not really my intention. Go that way if you want. I don't care. It's up to you. But well, guys, so tomorrow, pretty much I'll just take questions about the test for Monday. So if you got them, ask them. Well, off to proctor my computer lab. Yes?